Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, in this video, I'm going to choose or select a few questions from our tutorial books. Hopefully, it's going to help you to continue with the rest of the questions from our tutorial book. Okay, without wasting so much time, this is the first question. I'm not going to discuss the question number 1, which I think that is too easy. You may just refer to our lecture notes. So I'm going to choose a question from question 2, for example, might be this one here, B, D, E, F, or might be H. Okay, let's see. Might be not all these 5, might be 4 of them. Okay, so first question number 2B. A limit of H approaching to square root of -2 for the function of 3h squared minus 2 divided by h squared plus 4. Okay, with a limit of h approaching to negative square root of 2. Okay, in this case, if we directly substitute the value of h negative square root of 2 into the h and h, if it gives you something over 0 or might be 0 over 0, so we stop. Okay, we're not going to directly substitute the value of h into the function. We're going to do something else, might be from factorization or might be multiply with the conjugate. But let's say what is going to happen if we substitute here with 3h with square root of -2 square minus 2 divided by h squared, where h negative square root of 2 square plus 4. Limit h approaching to -2. Okay, we already substitute the value of h into the function, meaning that we don't have to write down the limit anymore, because the limit value of h or limit have been used. So negative times negative or negative square equal to positive. So we got 3, negative times negative positive, and square root with square cancel each other, then come up with 2 minus 2 divided by negative times negative or negative square equal to positive, and then square root with square cancel between this sign of square root with set with 2 and come up with 2 plus 4. So 3 times 2 equal to 6, 6 minus 2 equal to 4, 2 plus 4 equal to 6, and simplify this one as a 2 over 3. Okay, and then for question of 2D, limit of x approaching to 2 for x minus 2 divided by x cubed minus 8. Okay, I'm gonna try to recall, thinking of how are we going to factorize this, because if I substitute 2 here, 2 cubed equal to 8, 8 minus 8 equal to 0, 2 minus 2 equal to 0, it's meaningless that here. So I'm going to do separately here. Okay, maybe here, x cubed plus 0x squared plus 0x minus 8. Okay, with x minus 2, then x squared times x cubed, x squared times negative 2x minus 2x. Okay, 0 minus negative and negative positive, so 0 plus 2, 2x squared plus 0x. So then 2x squared divided by x plus 2. 2x times x, 2x squared, and 2x times negative 2 minus 4x. Okay, and then 0 negative times negative positive, so 0 plus 4, 4x minus 8. And then 4x minus 8, 4x divided by x plus 4, 4x, and 4 times negative 2, negative 8. Okay, so now limit x approaching to 2 x minus 2 divided by x minus 2, of course, and then this one here, x squared plus 2x plus 4. Okay, divide by itself, so it's come up with a limit of x approaching to 2, 1 divided by x squared plus 2x plus 4. So then substitute x equal to 2 here, 1 over 2 squared equal to 4. 2 times 2 equal to 4. And then plus 4. Then come up with 1 over 12. Okay. Now, question E. Question E. With the limit of x of p approaching to 9, then p minus 9 divided by square root of p minus 3. And again, if you substitute 9 here, square root of 9 equal to 3, 3 minus 3 equal to 0, then p equal to 9, 9 minus 9 equal to 0, 0 over 0 is undefined. So we avoid that. So we are going to come up with factorize this p minus 9 with a limit of p approaching to 9, and factorize this. You're going to give you square of p plus 3 and square of p minus 3 divided by square of p minus 3. So divide by itself, then p equal to 9, square of 9 here equal to square root of 9 plus 3 equal to 3 plus 3, and it equal to 6. Okay, now question F. Question F, a limit of x approaching to 0, e to the power of 2x minus 1 divided by ex minus 1. Now, e power of 2x minus 1 is just e power of 2x. It is equal to e to the power of x squared. Okay, so just imagine that if we, I will recall, replace this with something else. It's just like y squared minus 1 divided by y minus 1. Okay, we factorize y squared minus 1 with y minus 1 and y plus 1 divided by y minus 1. Okay, so we're going to implement this here. So it's going to be limit of x approaching to 0, e power of x minus 1 with e power of x plus 1 divided by ex minus 1. Okay, before that, what if I strictly substitute x with 0 into this function? E power of 0 equal to 1, and 1 minus 1 equal to 0. Okay, and x equal to 0, 2 times 0 equal to 0, e power of 0 equal to 1, then 1 minus 1 equal to 0, 0 over 0, so we avoid that. Then we have already substituted, we call factorize this, divide by itself, then limit x approaching to 0 for e power of x plus 1. So then here now, let's substitute with x equal to 0 plus 1, which is this one equal to 1. So 1 plus 1 equal to 2. Okay, so which I think that leave the answer, leave the solution for question H for you to try. And for this one here, do I need to show this? Let's see. Okay, never mind. Plus, because it's a video, you may just recall, reverse to see, recall the solution for question of D. So I'm gonna clear this. Okay, if you like to see the solution, if you like to see again the solution for question D, so you reverse, recall the video and watch again and again and again. Okay, so question H. For question H, then come up with a limit of x approaching to 2 for square root of x plus 2 minus square root of 2x divided by x squared minus 2x. Limit x approaching to 2. Okay. For this one here now, we are going to, okay, look at this one here. Substitute x with 2. 2 plus 2 equal to 4. Square root of 4 equal to 2. 2 times 2 equal to 4. Then square root of 4 equal to 2. 2 minus 2 equal to 0. 2 squared equal to 4. 2 times 2 equal to 4. So then 4 minus 4 equal to 0. 0 over 0 undefined. So what can we do here now is we're going to multiply everything here with square root of x plus 2 minus, then positive here, square root of 2x, then square root of x plus 2 plus square root of 2x. Okay, so you still remember the process of this? Okay, conjugate, so square root of x plus 2 multiplied with itself and come out with x plus 2. This one with this, and this with this, positive and negative cancel each other, so negative times positive, negative square of 2x multiplied square of 2x, and 2x. Okay, and then here now, x squared minus 2x multiplied with this one here, square root of x plus 2 plus square root of 2x. Then limit of x approaching to 2, x minus 2x equal to negative x. So come out with 2 minus x. Okay, x minus 2x come out with negative of x. So 2 minus x. And we're going to factorize this. Factorize with x and then x minus 2 and square root of x plus 2 plus square root of 2x. Okay, we cannot simply clear this 2 minus x with x plus 2. We need to do something with this one here. Make this one as a factorize this with negative of x minus 2. Okay, let's see here now. Negative times x, negative x. Negative times negative 2 equal to positive 2. Okay, so right now we got x minus 2 and x minus 2. Then we clear between this and this. Okay, negative multiplied with x minus 2 is we call changing from 2 minus x, because we wanted the term of x minus 2 equal with the term of x minus 2 in the denominator here. Okay, so then limit of x approaching to 2, negative 1 divided by x. This will be cleared by this one here now, and then square root of x plus 2 plus square root of 2x. Then limit x approach. Okay, we substitute the value of x equal to 2 here, so we don't have to write a limit again. Now for substitution, 1 divided by 2, and then 2 plus 2 equal to 4. 4 square root of 4 equal to 2 plus 2 times 2 equal to 4. Then square root of 4 equal to 2. Then negative 1 divided by 2 plus 2 equal to 4. 4 times 2 equal to 8. Okay, next. Okay, so let's take a look at the question here now. Okay. If I choose find the limit of following x equal to 2 for question number 3a. Okay. Question of 3a. The function of fx equal to 5 minus x for x less than 2 and x over 2 plus 2 for x greater than 2. Okay, so means here, let's come up with this number line of 2, and we got the domain of x less than 2 is for 5 minus x and x greater than 2. It's for the equation function of x over 2 plus 2. Okay, you may sketch recall to recall the graph of this. But for this one, we could just to find the limit for these two functions. So find the limit of the following functions. In this case, we will see what's going to happen if x approaching to 2 from left and x approaching to 2 from right. So this is the direction for x less than 2 and direction of x greater than 2. Opposite is a direction of x approaching to 2 from left, and this one is x approaching 2 from right. Okay, so the limit of x approaching to 2 from left, approaching to 2 from left, which function that related to this one here? Yes, 5 minus x. Okay, so then we substitute x with 2 here, then 5 minus 2 equal to 3. So the limit exists. Limit x approaching to 2 from the left of the function fx exists. And then limit x approaching to 2 from right. And approaching to 2 from right for the function of x over 2 plus 2. Okay. And now we substitute the x equal to 2 here. So 2 over 2 plus 2. Then this is 1. 1 plus 2 equal to 3. Limit x approaching to 2 from right of the function fx exit. Okay, find the limit of the following function at x equal to 2. So then, the limit of x approaching to 2. Okay, just now is limit x approaching to 2 from left and from right. Both exist and both are equal, 3 and 3. So we come up with the conclusion that limit x approaching to 2. Do you find any sign here? No. Meaning it's a general. Represent for negative, represent x approaching to 2 from left and approaching to 2 from right. And the limit of the function fx equal to 3. Okay, next question. I choose one of the questions here. E. Okay, for 4e. Find the limit of x approaching to 2 from left. Okay, for x squared minus 4 divided by modulus of x minus 2. Okay, before we continue with this one here, we refresh our memories about the recall definition of absolute values. Modulus of x minus 2, okay, it will divide into two parts here, two definitions. First is where x minus 2 for x greater than or equal to 0. In this case, x greater than 2. X greater than or equal to 2, and then negative of x minus 2 for x less than 2. Okay, so this is the domain for this and this. Now, x approaching to 2 from left. Okay, 2 for x greater than or equal to 2 and x less than 2. This is for x minus 2 and this negative of x minus 2. Okay, so when x approaching to 2 from left is coming to 2 from left, am I right? So which function that related or represent this? Yes, negative x minus 2. So then come up with a limit of x approaching to 2 from left and factorize this. X squared minus 4, come up with x minus 2 and x plus 2. Divide by negative x minus 2. Negative x minus 2. There you go. So come up with limit of x approaching to 2 from left, negative, multiply with this one here, negative of x plus 2. So substitute x with 2. 2 plus 2 equal to 4, and then negative 4. Okay. Now I choose question number 5a. Okay, I bring up here. Question 5a. Okay. Limit of x approaching to 0 from left of 4 divided by x cubed. Okay, class. Let me share with all of you something here. How do you get this? How I'm going to move out from this. Okay. If I out from this window, then come back, and then everything clear. Okay, never mind. It's gonna be like this. You may use any apps that you have in your smartphone or might be from your internet. Okay, just to see how the graph of this looks like. Okay, so reciprocal graph 4 over x cubed for this kind of graph. It will be something like this. Okay, and also here. Okay, now let's see. This is the movement of the graph, and also the movement of the graph of the shape of the graph. When x approaching to x from left, okay, when x approaching to x from left here, as you see that here now, the value of y approaching to negative infinity. Okay, so from here now, when x approaching to 0 from left here, so you can see here now the movement or the value of y 1 by 1. So you can see that the value of y getting smaller and smaller to negative infinity. So then we come up with the conclusion that it is equal to negative infinity. Okay, number 5a. And then if I choose another one, never mind, as I said that this is a video when I clear something actually that you already get the solution for this one, so copy it by yourself, and I clear this one. Okay, I think I need to connect a calculator here. Now, let's say question of E. Okay, question of E, limit x approaching to, question of 5, number 5E. 2 minus x divided by x minus 6 and x plus 2. Okay, for this question here, when x approaching to 6 from left. Okay, let's say this is an x and x approaching to 6 from left. As you know that, recall from the list of numbers here, from left is a 0, 1, 2, 3, 4, 5. 4 to 5 and approaching to 6 from left. So approaching to 6 from left, here we take any values of x, 5.7, 5.8, 5.9, 5.99 and so on. Okay, if we substitute the value of x approaching to 6 from left, 2 minus 6. 2 minus 6, the small numbers minus biggest number, then come up with negative value. Okay, now x minus 6. When x approaching to 6 from left, 5.9 less than 6. So 5.9 minus 6 come up with negative value. And then say x 5.9 plus 2 we come up with positive. Okay, so 2 minus 5.9 or 6, negative here. So negative value multiplied with positive, negative. And negative divided by negative equal to positive infinity. Okay, you just imagine that any value of x that very close to 6 from left. And just imagine that if you substitute here, here and here, and just think about the value of sign as negative, positive, and positive. That's all. Okay. Question number. Okay. That is for question number E here. So I straightly go through question number 6. Any selection from question number 6? Okay, question number 6. Question number 6. Let's say number 6b. 6b. This is 5e. So number 6b. Limit x approaching to negative infinity for x squared plus 4 divided by x plus 2. Okay, so that limit x approaching to negative infinity. So the highest degree of x in the denominator here is x, so we come up with x squared divided by x plus 4 over x divided by x over x plus 2 over x. Okay, so from here, x approaching to negative infinity is getting smaller with negative, so 4 over negative small big value, we come up with 0, 0, and this is 1. X squared divided by x, then only x left. So then, equal to this one here, x plus 0, sorry, okay, for this one here now, it is because limit x approaching to negative infinity is x plus 0 divided by 1 plus 0. So substitute x with negative infinity plus 0 divided by 1 is negative infinity. Okay, so then from here now, for question number F, 6F, I just leave it to all of you. Okay, number 5E, number 6B. I let all of you try by yourself. Let's take a look at question 7. Question 7. Limit of x approaching to P. Okay, for this one here, square root of P minus square root of x divided by px minus x squared equal to 1 divided by 2 square root of 10. So find the value of p. Okay, in this case here now, limit x approaching to p, square root of p minus square root of x divided by p with, okay, px minus x squared equal to limit of x approaching to p, square root of p minus square root of x divided by, okay, factorize p with x here, come out with x and p minus x, then limit of x approaching to p, square root of p minus square root of x divided by x, and factorize between p and x here, it's gonna give you square root of p minus square root of x and square root of p plus square root of x. Okay, so square root of p minus square root of x, clear between these two. Okay, I clear this. You already get the answer then here. Sorry if this kind of presentation is quite messy, but I do hope that all of you understood, because I'm going to try to discuss as many as you could in this one video. Okay, now equal to limit x approaching to p, 1 divided by x and square root of p plus square root of x. Okay, so let's compare now between this. Okay, substitute x with p here, so you come up with a limit of x, now substitute p, 1 divided by p square root of p plus square root of x with a p here. It is now become square root of p plus square root of p, 2 square root of p, then 2 and square root of p with p power of 3 over 2. Okay, now let's compare this with this one here now. How gonna be? Okay, so square of p plus square of p, 2 square of p, and then p is just like 2 square root of p multiplied with p, which is 2. P square of p is p power of 1 over 2 times p with power of 1, then come up with 2 p power of 3 over 2. So let's compare this with this one here. I think that for 1 over 2, 1 over 2 equal, right? So we just compare p power of 3 over 2 equal to 10 power of half. Okay, so multiply this with 2 over 3, and also this one here with 2 over 3. 2 divided by 2, 3 divided by 3, then p equal to 10 to the power of 1 over 3. Okay. Next, for question 8. Okay, for question 8, limit of x approaching to, fx equal to x cubed minus 1 divided by x minus 1. Okay, for this case, you may use the long division, and we come up and we factorize, simplify this as an x minus 1 multiplied with x squared plus x plus 1. Okay, to get these two, you recall x cubed minus 1 divided by x minus 1 using the long division. Okay, please refresh our subtopic of partial long division of polynomials. Okay, polynomials, and divide by x minus 1. Okay, now So fx equal to x squared plus x plus 1. So the question is, find the limit of x approaching to 1 of the function fx, x squared plus x plus 1 minus limit of x approaching to 0, x squared plus x plus 1. Okay, now just substitute x with 1. 1 square, 1 and 1. So 1 plus 1 plus 1 minus, okay, x approaching to 0, 0, 0 and 1. Then 0 plus 0 plus 1. Then come up with 3 minus 1 equal to 2. Okay. Okay, for question number 9 and 10, you try by yourself. Question number 11. Okay, given function of g y equal to, okay, y squared plus 5 for y that less than negative 2, and then 1 minus 3y for y that greater than or equal to negative 2. Okay, so from this number line, negative 2 here, we got less than, and the other one is greater than or equal. So find the limit of x approaching y approaching to 6. Okay. X approach y, geometric order function of here, limit of y approaching to 6 for gy. For limit of y approaching to 6 of the function gy. So class, let's say 6 is here. So if this for y greater than or equal to negative 2, so this is the domain for the function of 1 minus 3y, including y equal to 6. So if you like to find out the limit of y approaching to 6 from left, okay, please refer to the question directly then. Okay, this is domain of y greater than negative 2, including 6, so 1 minus 3y. So if y approaching to 6 from left and y approaching to 6 from right, we are referring to 1, this function of 1 minus 3y. So 1 minus 3y equal to, substitute y equal to 6, 3 times 6 equal to 18, so 1 minus 18, negative 17. Okay, number 11 here. Negative 17. And also limit y approaching to 6 from right. When y approaching to 6 from right, we also referring to the same one function, 1 minus 3y. Then we come up with, they write down with 1 minus 3y. Substitute y equal to 6 here, 3 times 6 equal to 18, 1 minus 18, negative 17. So limit y from the left exists, limit y from the right also exists, and the limit are equal. So we come up with a conclusion that limit of y approaching to 6 in general, okay, for the function of 1 minus 3y equal to negative 17. Okay, now limit y approaching to 2, negative 2 from left. When y approaching to negative 2 from left, so which function that related to this? Y less than negative 2. Okay, y approaching to negative 2 from left, and this is the one which is y squared plus 5. Substitute y with negative 2. Negative 2 squared is 4. 4 plus 5 equal to 9. and the limit of y approaching to 2, negative 2 from right. Y approaching to negative 2 from right, then this is a function here, 1 minus 3 times negative 2, sorry. Times negative 2 equal to negative, negative, positive, so 3 times 2 equal to 6. 1 plus 6 equal to 7. Okay, so number 11. Okay, the limit from limit y approaching to negative 2 from left exists, which is equal to 9. And limit y approaching to 2 from right, function of this, it exists, which is equal to 7. But the limit from the left and right are not equal. So we come up with the conclusion that limit x approaching to negative 2 of the function of gy does not exist. There you go. Okay. Then next, if I choose, let's say, I put up here now, question number 12. Okay, question number 12. Question A. Okay. Determine the vertical and horizontal asymptote if any of the following function. Question number 12a, the function of fx equal to x squared divided by x squared plus 1. Okay, limit x approaching to infinity, whether negative or positive, is same. Okay, so the highest degree of x from the denominator is x squared, so we divide x squared divided by x squared divided by x squared over x squared plus 1 over x squared. Okay, x approaching to positive or negative infinity. Let's imagine that it's a 1 here, a 0, and this is 1, and this is also 1. Come out with 1 divided by 1 plus 0 equal to 1. Okay, by the way, this is for horizontal asymptote. HA, horizontal asymptote, y equal to 1. For vertical asymptote, okay, let's see now for the function of x squared divided by x squared plus 1. Can we factorize this of x squared plus 1? If the question given here for x squared minus 1, then we come up with factorization of x minus 1 and x plus 1. Then the vertical asymptote, which is here, is x equal to plus minus 1. But for this case, x squared plus 1, we cannot factorize unless we get it in the term of complex numbers. So we are not talking about complex numbers here. Okay, so meaning that vertical asymptote does not exist. Okay. Okay, if I choose another question, number 12, okay, F, question F. Okay, question F, fx equal to x squared divided by x squared minus 9. Okay, from here, that we can simplify this or factorize x squared divided by x minus 3 and x plus 3. So from the denominator here, we can come up with the conclusion that the vertical asymptote which is x equal to negative 3 and x equal to 3. So you just imagine that okay, so if I come up with sorry, x and y, and then x equal to negative 3 and x equal to 3. From this equation, x squared divided by x squared minus 9, factorize x squared minus 9, come up with x minus 3 and x plus 3. So from here, as we know that x cannot be equal to negative 3 because x cannot be equal to 3. 3 minus 3 equal to 0. 3 plus 3 equal to 9. 9 multiplied with 0, 0. So something over 0, undefined. So that's why x cannot be equal to negative 3 and x cannot be equal to 3. Automatically, this is the vertical asymptote where x equal to negative 3 and x equal to 3. And also, this is the we can determine the domain of this function, which is negative infinity until negative 3, union negative 3 until 3, union 3 to positive infinity. So, the denominator can give us 3 information here. Okay, 3 information. The first is x cannot be equal to negative 3 and 3, and x equal to negative 3 and 3 is the vertical asymptote, and the domain is all real numbers except for negative 3 and 3. So 1, 2, 3. All the information here. Okay, now let's say, okay, if I make something like this, okay, and also here, this is x equal to 3 and this is x equal to negative 3. Okay, now we are going to analyze where is the direction of the graph when x approaching to 3 from left. Is either moving up or going down. Okay, x approaching to 3 from right, negative 3 from right, is either going up or going down. Going up or down and so on. Okay, you may use any apps or function of graph to see, okay, to see by yourself the shape of this graph. So vertical asymptote negative angle 3. So when limit of x approaching to negative 3 from left of the function of, okay, for this one here, x squared divided by x squared minus 9. Okay, negative 3 square and square here. So just imagine that negative 3 from left, negative 3.1. Okay, negative 3.1 square equal to positive. Okay, and negative 3.1 negative square is positive, but 3.1 square equal to 9.61. 9.61 minus 9, positive. So positive divided by positive, positive infinity. So graph will be something like this. Okay, and okay, looks terrible here. Limit x approaching to negative 3 from right of x squared divided by x squared minus 9. Negative 3 from right. So from 0, negative 1, negative 2, negative 2.5, negative 2.7, negative 2.99. Negative 2.99, okay, 2.9 squared, which is equal to 8.41. Okay, negative square is positive. So 8.41 minus 9, then of course it gives you negative, right? Divide by negative. Negative 2.9 squared equal to positive. Positive divided by negative, negative infinity. So graph when x approaching to negative 3 from right is approaching, graph is going sliding down, approaching to negative infinity. Okay, intersection at y. Intersection at y, x equal to 0. 0 divided by 0 minus 9 equal to 0. So the graph intersect here. Okay. Limit x approaching to 3 from left. Okay. Limit x approaching to 3 from left of the function x squared divided by x squared minus 9. Okay. From 0, 1, 2, 2.5, 2.7, 2.8, 2.9, 2.99. Okay. Just imagine there's a 2.9 here. 2.9 squared is positive. Then 2.9 squared. 2.9 squared is 8.41. 8.41 minus 9 equal to negative value. So positive divided by negative equal to negative infinity. So the graph will falling down again. And then the limit of x approaching to 3 from right. For x squared divided by x squared minus 9. Okay. At 3 from right. Okay, just imagine it is 5, 4, 4.3.5, 3.2, 3.1, 3.11, 3.01. Okay, 3.0 or 3.1 greater than 3. Okay, 3.1 squared is positive. 3.1 squared is 9.61. 9.61 minus 9 equal to positive 0.61. So positive divided by positive, positive infinity. Then the graph is moving up. Okay, so this is a graph of x squared divided by x squared minus 9. And for horizontal asymptote, okay, limit x approaching to infinity of x squared. Look at this one, the highest denominator, greater denominator here is x squared. So x squared divided by x squared divided by x squared divided by x squared minus 9 over x squared. This is 1, 1, 0. Then can come out with 1 divided by 1 minus 0. And is equal to 1. So vertical asymptote from left and right, we got approaching to positive infinity, negative infinity, and positive infinity. But then for horizontal asymptote, it is equal to 1. Okay, so in the f of function, you just substitute this fx and you can see by yourself how the graphs looks like. Okay, question number 12f. Okay, never mind. Okay, if I look at question of 15. Question 15, fx equal to x squared minus 9 divided by x minus 3 for x that is not equal to 3 and equal to 6 when x equal to 3. Okay, the continuous now. Find the values of x where the function is continuous. Continuous means that limit x approaching to a from left of the function fx equal to L. Okay, and the limit x approaching to a from right fx equal to L. And when a function of f a itself also gives us the same value. So the condition of limit, okay, being fulfilled, and also the function of when x equal to a also equal to L. So these three conditions will be fulfilled. That is then the function, we say that the function of fx is continuous. Okay, now limit x approaching to, okay, for this one here now, this is 3. When x exactly equal to 3, then function is 6. And when the function is not equal to 3, then there is a x squared minus 9 divided by x minus 3, and x squared minus 9 divided by x minus 3. By the way, x squared minus 9 divided by x minus 3 equal to x minus 3 x plus 3 divided by x minus 3. So actually we're talking about the function of x plus 3. Okay, so this is the one. We can simplify this as an x plus 3. So when x approaching to 3 from left, x approaching to 3 from left, then come up with x plus 3. So substitute x with 3 plus 3 equal to 6. Limit x approaching to 3 from right for x plus 3. Simplify this, x squared minus 9, x minus 3, x plus 3 divided by x minus 3 in here, and then substitute x with 3 plus 3 equal to 6. So the limit from x approaching to 3 from left, x is, limit from x approaching to 3 from right, x is, and they are equal. And let's see, limit, the function of f when x equal to exactly 3. When x is exactly 3, then y equal, fx equal to 6. So find the value of x, then the value of x equal to 3. So for the function fx continuous. Now let's take a look at question number 16. You may try yourself with question number 17. Okay, question 16. Let hx equal to 3x squared minus 6 and 8 minus x. X less than 2 and x greater than or equal to 2. So from this number line here, for x less than 2, then is for the function of 3x squared minus 6 and x greater than 2, okay, is for 8 minus x. Okay, now discuss the continuity of h at x equal to 2. Okay, let's find out the limit first. For 16, h is continuous at x equal to 2. Okay, continuity means that we need to consider limit of x approaching to the value of a, a value of a, in this case is 2 here, from left from right, and when x exactly equal to the value. So right now, for limit of x approaching to 2 from left, x approaching 2 from left, that is for 3x squared minus 6. Substitute x with 2 here, 2 squared equal to 4, 4 times 3 equal to 12, 12 minus 6 equal to 6. Then limit x approaching to 2 from right. When x approaching 2 from right is for the function of 8 minus x. So x equal to 2, 8 minus 2 also equal to 6. But for x greater than or equal to 2, for equal to 2, means that x equal to 2 for this function here. So f2, which is 8 minus 2, also equal to 6. So that this function is continuous function, okay? The function of hx is continuous at x equal to 2. Okay, limit from the left of 2 exists, limit from right also exists, they are equal to 6, and then when x exactly equal to 2 also equal to 6 means that it's continuous at x equal to 2. Okay, so which I think that for until question 60 is enough for our discussion. Do we need to look at another one? Question number 20. Question 20, the function of fx equal to x squared plus 3 4x less than 1, b for x equal to 1, then ax plus 2 for x greater than 1. If continuous on interval of negative to positive, find the values of a and b and sketch the graph of fx. Okay, meaning if mentioned here is if the function fx continuous on the interval of from negative to positive infinity, meaning that this graph of this and this smooth before x, okay, let's say this is 1 here, graph might be something like this, smooth until it reach at x equal to 1, and when x is exactly 1, and then it's continuous journey here. So before and after, and when exactly x equal to 1, they are connected. Okay, if that's so, limit of x approaching 2 from here, from 1, x approaching x less than 1 for x squared plus 3, x greater than 1 for ax plus 2, and when x is exactly 1, then equal to b. So limit x approaching to 1 from left of the function of x squared plus 3 equal to b. Okay, substitute x in 1 here, 1 squared plus 3 equal to b. So 1 squared is 1, 1 plus 3, then b equal to 4. And then limit of x approaching to 1 from right. X approaching to 4, well, from 1 to 1 from right, with the equation of ax plus 2 equal to b, which is b equal to 4. So substitute x with 1 here, a times 1 equal to a plus 2, that equal to 4, then a equal to 4 minus 2 equal to 4 minus 2 equal to 2. Then the function of fx equal to x squared plus 3 for x less than 1, b equal to 4, and x exactly equal to 1, then a equal to 2. 2x plus 2 when x greater than 1. Okay, so the question wants us to sketch the graph of fx. Okay, this is an interesting part, which I think that all of you love. When sketching a graph, it's getting more interesting, hopefully. Okay. Now, the graph of x squared plus 3. Let's say the function of f1 x equal to x squared plus 3. When x equal to 0, y equal to 3. This graph does not intersect at what x-axis, so it's just something like here. Okay, this is a function of x squared plus 3. So this is a graph of y equal to x squared plus 3. By the way, this graph is, we call, only for the domain of x less than 1. So let's say if there's a 1 here, okay, so then until up here, this is the whole the graph of x squared plus 3 for the domain from negative to positive infinity. But once we limit the domain x less than 1, meaning it's just part of this graph, then begin from here. Okay, the graph of x squared plus 3. Sorry for that. And then what are we going to do now is to erase this. Oh no, sorry. There you go. This is part of the graph for x squared plus 3 for x less than 1. And then when x exactly equal to 1, okay, when x equal to 1 here, 1 squared equal to 1. 1 plus 3 equal to 4. And when x exactly 1, then y equal to 4 is here. Okay. And then for the graph of 2x plus 2, f2x for x, no, 2x plus 2. So when x equal to 0, y equal to 2. And when y equal to 0, just imagine that then x equal to negative 1. Okay, so let's find out now. 0 and 2. 0 and 2 might be somewhere around here. 0 and 2, and then y0, x negative 1. Okay, this is the graph. 0, y equal to 2, and then 0, negative 1. It should be something like this. Okay, it's a linear graph with something like this. Okay, when x equal to 1, 2 times 1 equal to 2, and 2 plus 2 equal to 4 here. Okay, now for this graph, is where for the domain for x greater than 1. For x greater than 1 means that it's peaking here. Okay, so what are we going to do now is we are going to clear or erase this. There you go. Okay, the curve of x squared plus 3, the coordinate of 1 and 4, and then linear of 2x plus 2 on the other side. Okay, so this is the graph for the question 20. Okay, I do hope that it helps you to complete all the tasks, and that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and good luck for your final examination. That's all.